Welcome everybody. I'm recording this again. My first recording didn't work out so well. I was falling asleep. So let's try this a little bit better this time. So we are starting chapter 11. We'll get through it all. It's a pretty quick chapter. This is all about three-dimensional shapes. So our first learning target here is 11A, 3D basics. So take a look at these shapes. What do you call these shapes? Try and come up with a name for each of them. Pause the video right now as you try to come up with a name for each of them. I'm going to give you one hint. This is called a triangular prism. Prism, P-R-I-S-M. Okay, so what do you call the others? All right, let's see how you did. If this is a triangular prism, it's called a triangular prism because we have a triangle here. It's kind of like we're stacking these triangles next to each other to make the prism. So this is a whole bunch of triangles stacked next to each other. In the same way, here we have a rectangle that's stacked and stacked next to each other. You could think about the top like a square that's stacked on top of each other, but if you do that, you notice that it's still not creating another square or anything. It's creating a big rectangle. So we call that a rectangular prism. Here we have a five-sided figure. Oh, so that's a pentagon. And it's like a whole bunch of pentagons stacked on top of each other. That's called a pentagonal prism. And then this one has 6 sides, so it's a hexagon. This is not a regular hexagon. This one looks like it's a regular pentagon. But this one's not a regular hexagon. It's a hexagonal prism, though. So we have each of our prisms here in our basic shapes. A triangular prism, a rectangular prism, a pentagonal prism, and a hexagonal prism. Go ahead and write their names down here. And think about this question. What do you call a prism with a decagon as its base? Okay. If you were thinking it was called a decagonal prism, you'd be correct. D-E-C-A-G-O-N-A-L, decagonal prism. Okay, we use the number of sides to describe it. Whenever we get to sides that don't have exactly easy names, we could call something a 30-sided or a 30-gon prism. 30-gonal prism. All right, so our big goal here in learning about these 3D basics is to learn how to name things, learn how to describe things. Now let's get to this beginning of the concept. What is a corner? Take a look at these shapes. Think about what a corner is for these shapes. In 2 dimensions, a corner is pretty simple. A 2-dimensional shape, a corner would be kind of like a vertex of this shape. That would be a corner. But in 3-dimensional shapes, is a corner a whole slice of it? Like that would be a corner of the 2-dimensional shape. You just cut it off right there. Or is it like this diagonal cut, like you cut diagonally and you get that? What is a corner in 3 dimensions? And it turns out that a corner here does not have a name. A corner has no standard 3D definition. Now, I could ask you, we live in 3D, and I could tell you guys to go to the left or the back corner of the room, and you'd know where I was talking about because you take that 3D image of the classroom and you turn it into like a 2D place because we walk on the 2D plane, and you'd be able to go to that back corner without too much work. But whenever we consider it to be a 3D plane, that corner doesn't, or a 3D structure, that corner doesn't really have a definition. So as we go through these 3D shapes, we need to come up with better names to describe them. And there are 3 names that we use to describe parts of these shapes. In our prisms here, we'll get through this example. This triangular prism has a triangle in the front. It's got this rectangle on the side. It's got a triangle in the back, another rectangle across the bottom, and another rectangle over here. Each of those is a face of the shape. A face is a two-dimensional plane that provides structure to the shape. Okay? And a face of a 3D object is the two-dimensional planes that make it up. So this is made up by 2 triangles and 3 rectangles to make that triangular prism. I could look at this and it looks like those are squares, so I could say 2 squares and 4 rectangles for this one. This is a face of a 3D object. All right, take a second to write that down. A face of a 3D object, and I think I typed that in a little bit differently. So let me get rid of that. Is the two-dimensional planes that make it up. All right, a face of a 3D object is the two-dimensional plane that makes it up. All right, with that said, there are other things for us to be able to get, but before we do, go to each of these prisms and I want you to number them. How many faces does each one have? I'm going to give you the first one for a triangular prism with those 2 triangles. That's 2, and then the 3 rectangles. That is 3 for a total of 5 faces. How many does the rectangular prism have? What about the pentagonal and what about the hexagonal prism? Go ahead and number them right here. How many faces does each one have? All right, I'm going to try something else. I just learned how to do this. Yeah. It's the two-dimensional plane that makes it up. All right. So now we've gone through each of the faces of this object. And the second definition that works in 3 dimensions, doesn't apply in the same way to 2 dimensions, is an edge. Now, if I were to have you look over here and think, what's the edge of this shape? You'd probably be pretty accurate in taking the 2-dimensional idea and bringing it to a 3-dimensional idea. Hopefully, you ended up picking an edge like this, or like this, or this, or this, or this, or this. An edge is where 2 faces in our prisms or our other 3-dimensional shapes actually meet. Okay, an edge of a 3-dimensional object is the intersection of 2 planes or faces of that object. All right, so we've got our second definition here for a 3-dimensional object. Okay, so as we go through that, how many edges make up this shape? If I were to count the edges on this triangular prism, I would count 1, 2, 3, 4, 5, 6, and then I've got 7, 8, and 9. There are a total of 9 edges. All right, go to the other 3-dimensional prisms and go ahead and write down their number of faces. Pause the video while you do so. All right. Now, let's talk about our last one, the vertices of that object. The vertices of a 3-dimensional object are the places where 3 or more faces intersect. So if I take a look here, I can see that this face meets with this face and with this face. So all 3 faces meet at this one point. That's our vertex. And if I count 1, 2, 3, 4, 5, 6 vertices make up that shape. So I can write that down, 6 vertices. Pause the video and go ahead to all of the other prisms and get their number of shapes as well. All right. So for your prisms, you should have come up with this number of faces. For a rectangular prism, you've got the 2 faces for the top and the bottom, plus the 4 faces. So I'm going to put 2 plus 4 here. 2 plus 4 should be a total of 6. For the pentagonal, there's 2 pentagons, plus 5, which is 7. And for the hexagonal, there's 2 plus 6, which is 8. And hopefully you're starting to notice the pattern there. All right, what about with edges? Oh, edges, seems like there's quite a bit. For the rectangular one, we've got 4 on top, 4 on bottom. That's 8, 9, 10, 11, 12. Oh, there's 12 here. 9, 12. The next one actually has 15, and the next one has 18. What about vertices? Well, there are 6 vertices for the first one. There are 8 vertices for the rectangular prism. There are 10 vertices for the pentagonal prism and 12 vertices for the hexagonal prism. So we're able to get all of those. All right. I want you to take a second and see if you can come up with some general formulas for these faces, edges, and vertices. Okay? Again, pause the video. All right. Hopefully, you began to notice that if we look at the shape of the base, okay, so 4 prisms, and let's write that down, 4 prisms. Let n be the number of sides of the base, okay? Then the number of faces is going to be n plus 2. The number of edges is going to be 3 times n. Notice triangular prism is 3. 3 times 3 is 9. 4 times 3 is 12, so that's 3n. And the vertices is going to be 2 times n. All right. With that said, we're going to pause right there. There'll be a second video for you to take a look at. Oh, I did forget to put the vertex one up there. All right, vertex is a point on a 3-dimensional shape where those points meet. All right, I will make a second video in just a second and get it shared.